did it again. It's not 8.3, it is 13.3. All right. Now, you're going to have to recall some information from geometry, because we can make some generalizations for trig. Isn't an isosceles triangle where it has two equal sides? Isosceles right triangle, where the legs are the same. Does anybody remember the ratio of the sides to the hypotenuse? If the sides are 1, square root of 2. Okay? And so the ratios are the same. And what can you tell me about those other two angles? They're 45s. Okay, so we have two 45-degree angles and one 90. So we have these, what we call special angles. The special angles are, well, 0 degrees, which we'll talk about in a minute. 30 degrees, 45, 60, and 90. Those are your special angles. And if I want to find the sine of 45 degrees, because the ratio is the same, no matter how big that triangle is, that ratio is always the same, similar triangles. The sine of 45 degrees is opposite over hypotenuse, which is square root of 2 over 2. So in a right triangle, the sine of 45 degrees is square root of 2 over 2, no matter how big that triangle is. Okay? And what is the cosine of 45 degrees? Well, adjacent over hypotenuse, isn't that the same thing? Which is 1 over square root of 2, which is square root of 2 over 2. So the sine of 45 degrees is the same as the cosine of 45 degrees, square root of 2 over 2. That's an exact answer. What is tangent? What is tangent of 45? 1. Because as we learned the other day, yesterday, sine over cosine is equal to tangent. And square root of 2 over 2 over square root of 2 over 2 is 1. So we're making some generalizations about these special angles. We also learned a special angle in geometry of a 30, 60, 90. Does anybody remember that ratio? Well, the hypotenuse is twice the shorter leg, and then the longer leg would be square root of 3. And you could use Pythagorean theorem to verify that. Okay, well, let's find out what the sine of 30 degrees is. Can you tell by looking? What's the sine of 30? Opposite over hypotenuse, 1/2. So the sine of 30 degrees is 1/2. What is the cosine of 30 degrees? Or, I'm sorry. Yeah, what's cosine of 30 degrees? Square root of 3 over 2. Who could tell me what the cosine of 60 is real quick? 1/2. Because? Perfect. The sine of 30 is equal to the cosine of its complement. The complement of 30 degrees is 60 degrees. And so if the sine of 30 is 1/2, then the cosine of 60 is also 1/2. So we could come up with these generalizations on these special angles. And what we're going to do is we're going to make a chart. for sine, cosine, and tangent. Here's our theta. Okay? Our special angles, 0, 30, 45, 60, and 90. All right, so here's what we've sort of picked up from our triangles there. We said that the sine was the square root of 2 over 2, and we said the cosine was square root of 2 over 2. And the tangent of 45, which is sine over cosine, is 1. Okay? And we figured the sine of 30 degrees was 1/2. Okay? Now, let's talk about 0 degrees. We'll get the others in just a minute. And I'll show you an easy way to remember that. Let's take a ray. First of all, let's take let's say we have a ray that's 0 degrees. Okay? We're not revolving that ray anywhere. Would you agree that the radius of this circle is the same as the x value? And sine of theta is the y value over the radius. What is the y value? 0. So sine of 0 is 0. And the cosine of theta, which is x over r, and we agreed that the value of this x, whatever it is, over the radius is the same. So the cosine of 0 would be what? 1. So cosine of 0 degrees is 1. What is tangent? 0. Sine over cosine. The sine of 60 degrees is the square root of 3 over 2. What about the sine of 90 degrees? Here's 90-degree rotation. And if I want the sine of 90 degrees, it's the y value over r. The y value and the radius are the same. The sine of 90 degrees is 1. Your calculator will handle the axes. Sine of 90, it'll give you 1. All right? Now, if you look at this first column, where the sine of 0 is 0, the sine of 30 is 1/2, the sine of 45, I try to give my students a pattern. Here's a pattern I noticed. Square root of 0 over 2. Isn't that 0? Square root of 1 over 2. 1/2. Square root of 2 over 2. Square root of 3 over 2. And the square root of 4 over 2. Which is 1, right? So it's kind of a pattern to remember this first column, because we need to commit that to memory. And do you know that cosine, that pattern, is a reverse of sine? So that cosine of 1, or cosine of 90 degrees is 0. Cosine of 60 is 1/2, same as sine of 30. And the cosine of 30 degrees is square root of 3 over 2. Tangent is sine over cosine. it's the y value over the x value, the 1 over square root of 3, which is square root of 3 over 3. For 60 degrees, it's the y value over the x value, square root of 3 over 1. And for 90 degrees, it's sine over cosine, 1 over 0, which is so it is undefined, not 0. So tangent 90 degrees undefined. You need to memorize this chart. How do you memorize the chart? Memorize the first column. Because if you know the first column, the second column is the reverse of the first. And if you know what sine and cosine are, then you can figure out tangent. Because tangent is sine over cosine. So it's really not that hard, but you have to memorize it. I told you a lot of memorizing in trig. Okay? So, how does that help us? Well, find sine of 240 degrees. Find the sine of 240 degrees. That's not on our chart. But the reference angle is, what's a reference angle? 60. The reference angle is 60. Okay. And what's the sine of 60? Square root of 3 over 2. So what is this? What quadrant are we in? Where is 240? Third. Isn't that easy? Yeah, once you get it memorized. And that's what I said, because your homework will go by so quickly. So will your test. What is cosine of 240? Reference angle of? That's 1/2. What quadrant? Third. Cosine is? Negative. What is tangent of 240? Square root of 3. Positive or negative? Positive. Okay? I can easily figure out cosecant, secant, and cotangent if I need to, because they're just reciprocals. Okay? So we can use reference angles. Now we got a whole bunch of angles. Not only do we have 0, 30, 45, 60, and 90, we also have 120, 135, 150, and 180. We also have 210, 225, 240, and 270. And then we also have 300, 315. It's 300? Yeah, 300, 315, 330, and then 360. Okay, so we can go all the way around. Okay, by using reference angles and by knowing what's positive and what's negative into each quadrant. All right. Are we having fun yet? Because the fun's just beginning. It's not hard. The math on it's not hard, but there is memorizing. The math on it should be easy for you. All right, let's take, and if I can do this correctly, which I think I can. Yes. All right. I just didn't want the numbers there because my drawings are not exact, especially when you're doing circles. And you probably noticed that my artistry skills are not the greatest. But so, given a circle, is that relatively centered? Yeah, I know you can, but I'll get to it. By June, I'm really going to know how to work this smartboard.
Your circle is open.
I know. I knew you would notice. But let's say we rotate a ray let's say 150 degrees. So we're going to start here and we're going to rotate a ray 150 degrees around this circle. Okay? And so we have 150 degree rotation. Here's our theta. And let's say the radius of that circle is, 5. Okay? What I want you to tell me is what is the point on that circle? It's going to be an x and a y, isn't it? What's a point on the circle? All right. Here's how we do this. Our reference angle is 30. Now the sine of an angle I know is y over r, and I know the cosine of an angle is x over r. And what am I looking for? Well, I'm looking for a point. I'm looking for the point x and y. And let's use a reference angle so that the sine of 30 degrees, the reference angle, is equal to the y over the r, which is given as 5. So how do I find the y? Multiply both sides by 5. 5 times sine of 30. That's your y value. I know what sine of 30 is. Sine of 30 is 1/2. And so the y value is 5/2. That's the y value. What is the x value? Kind of the same thing. If I multiply both sides by r, I have r times cosine of theta. That gives me the x value, doesn't it? And I gave you the radius as being 5 times cosine of 30 degrees, the reference angle. That gives me the x. Cosine of 30, as you'll discover, is square root of 3 over 2. So I have 5 square root of 3 over 2, and that's my x value. However, cosine in the second quadrant is 150 degrees in the second quadrant. Cosine is negative. So if I'm looking for the point on a circle with a radius of 5 with 150 degree rotation, that point is at negative 5 square root of 3 over 2 and 5/2. And that's how you find your x and y. So to summarize, to find the x and the y, it is r cosine theta, the radius times the cosine of the angle, and r sine theta will give you the y coordinate. If they're given a special angle, I want exact answers. I don't want decimals. Maybe I'll tell you 100 degrees with a radius of 3. The reference angle is 80. That's not one of our special angles, is it? So to find the x-coordinate, it is r cosine theta. To find the y-coordinate, it is r sine theta. So it'd be 3 times cosine of 100. How do we figure that out? Put it in your calculator. Round it to the nearest whatever it tells you to. And to find the y-coordinate, it is 3 times sine of 100. You don't have to worry about which is which. This will give you a negative number. If you plug in 3 cosine 100, you will get a negative number. And if you plug in 3 sine 100, you'll get a positive number. Because sine is positive in the second quadrant, cosine is negative. So we'll take care of your positives and negatives for you. Is that clear? I don't know if you have any like this in homework with given a radius and given an angle that's not special. I think they do have special angles here. One more. Okay. Now we're going to have something called it looks like an Easter egg, doesn't it? Let me try again. I know there's a way to draw a circle. Oh, that's horrible. Who can draw a circle in here? Push the button. All right, push which button? Tell me what, this one. And then press the circle. What happened?
And then make the size that you want.
Draw the circle. Drag it.
No.
You said drag it.
No, I mean like drag it on the board and it'll.
Oh, I get you. Well, now I don't want. Oh, see. And this is going to be recorded. All right, hold on. See, if your parents see that, they're going to see what. All right, so let me do it again. Oh, the end of the radius?
No.
The center.
Yeah.
Now unclick that button. There you go. Okay, go. You're good.
Good.
No, it's not a marker. It's not a marker.
All right. Now we have a radius of 1. And this is called a unit circle. This is a unit circle. Radius of 1 unit circle. So a unit circle has a radius of 1. Okay. There's going to be a quiz question. There's going to be a quiz question next week. It will look like this. Give the coordinates of the point on a unit circle with a 250-degree rotation. Okay? Here's 180, 250, it's probably about here, isn't it? And this will be about a 250-degree rotation. and I want the coordinate of a point on the circle, on the unit circle. Okay? Now, I don't want you to bring your test up to me and say, Mr. Joseph, there's no radius here. The radius is not given. How do we do that? A unit circle, the radius is given. The radius is 1. And so in order to find that x and y coordinate, we know the x coordinate is r cosine theta, but the radius is 1, so it's simply cosine theta, right? 1 cosine theta is just cosine theta and sine theta. So in order to find it, it is cosine 250. That's not a special angle. That'll give you the x coordinate and sine of 250. And I'll bet if you put that in your calculator, in fact, would you do that for me? And what is the cosine of 250? Negative.
0.34.
And sine of 250, I know it's negative.
0.93 or 94.
Yep, I know it's negative because I'm in the third quadrant. And sine and cosine are both negative in the third quadrant. And if you look at this point here, of course, it's a negative and a negative. Okay? So your homework, you will have a little time tomorrow to work on it in class. Do as many as you can, however, tonight. We'll be on pages 848 and 849, 8 through 98 evens. There will be a review tomorrow, so don't count on taking the whole class to do that tomorrow. All right, so do as many as you can. You'll be really good at it.